Assalamu alaikum wa rahmatullahi wa barakatuh. Hey everyone, my name is Abu Bakr Abdurrahman, and in today's video we will be talking about how to build a CI/CD pipeline for Spring Boot application and deploy it using GKE, Google Kubernetes Engine, which is a managed Kubernetes service. So we'll build our application locally and develop it, build it, test it using Maven, containerize it into an image, and push it to Docker Hub. So we'll be doing the whole procedure, locally on our laptop, and then if it, works perfectly, we will access it from the internet. If everything is great, we will, then, build the CI/CD pipeline and, go from there and deploy it on GKE. So hope you liked today's video. Without further ado, let's get into it. Okay. So first, already cloned my GitHub, repo, and the application that we'll be building is a coffee house application. So let's open my Git, and we'll go into downloads, locate where our, GitHub repo cloned app is. Okay. So cd into that folder directory, cd coffee house -DevOps -project. Okay, perfect. So to verify and figure out which branch we're currently working with, we will hit git branch. So as you see, we're on the test branch. So in a software development lifecycle, the best practice is to, when dealing with GitHub repo, it's to, use a feature branch, and, after you clone it from main, you create a feature branch, and, that's where you update everything and, test your version and write whatever you're going to do and update the file. Afterwards, you deploy it on GitHub repo, not on the main branch. You deploy it on a separate branch, also the test branch, which is the test branch. And then afterwards, you will have basically a CI/CD pipeline sitting on your test branch, and if it passes the building, testing, and stage and everything, and there's no bugs in it, you create a pull hub. You create a pull request, and in which the team will review it, or a senior higher level will review it, and if it's okay, he will merge it into the main. But most importantly, you don't directly merge it into main without having a CI/CD pipeline in order, because it will test your application if there's any bugs into it. So yeah, so let's see, we have our application over here on the feature branch, and so as you see, the source file is what we're going to build. After we build it and test it using Maven, a target and directory will be created, which will contain your application. Let's see. Yeah, it will contain your application after it builds it and tests it and compiles it into a jar file. So let's go back. Okay, let's hit Maven clean to clean the target file. Let's say this is my first time building the application and we don't have a target file. Maven clean. That's rather odd. Let me go to VS Code, because I'm pretty sure I need to have a Maven plugin installed, which I already did install it on VS Code. CD downloads. So yeah, am I dealing with Ubuntu? Okay, perfect. CD coffee house -DevOps -project. Oh, little misspelled over there. Okay. Git branch to check, which branch I'm dealing with. Test branch. Okay, perfect. So let's say ls Maven clean. Perfecto. Okay, so I cloned my GitHub remote repo, which is a coffee house, Spring Boot application. So I cloned it locally into my laptop. And if you want the command, it's git clone, and then you go to the code over here, and then you copy the HTTPS and you paste it over here, which clones the remote repo to your local repo. So after I cloned it, to check which branch I'm currently working with, you can run git branch. As you see, I'm dealing with the test branch, the feature branch. Okay, perfect. So when you're building a Spring Boot application, after you build it using Maven, a target directory will be created, which is where your temporary built application will be stored in, and the format will be jar, J-A-R. So let's build it real quick and see if it works locally. Before we do that, if you want, we could get into the Docker file and see the contents. So I'm specifying that I want to build this container using the image Eclipse tmarin 21-jdk, and the workdir command specifies the working directory inside the container. So it will create this directory /app, and it will instantly switch to it, which will make it the working directory. And the copy will copy the application that was built after we run the Maven build command. And and here I'm specifying copy from the target folder directory, copy any file that starts with jar and put it in app.jar. And then afterwards we'll expose our application in port 8080. And entry point is just a command to defaultly execute when the container starts. So let's get back. And we will run Maven spring -boot .run. This will build the application, test it, and deploy it on a temporary directory, which is the target one. So it's already running. We will go to the internet and check the endpoint, http://localhost, and if you remember, we deployed it on port 8080. Wow, there you go. It's working perfectly locally. As you see, this is a little, and coffee house brew bean, website that I built. Nothing too fancy, nothing too big. So it contains, a little information, homepage, a menu page, containing all the different cafes and whatnot and its prices. And there goes the about page, which displays a little information about the coffee and since when it was running, the whole, coffee brew bean branch, basically. And if you want to contact them, I built them a contact page, and specifying its address and their phone number if you have a complaint and would like to call them, and an email you could reach them on, and as well as the opening hours. Even so, if you want to send them a message, you can just type in your name here, your email here, the subject, what's this complaint about, and your message. Perfect. So it's working locally. Now what we want to do is we want to run it from a container. We will build it and package it into a container image, and we will run it from a container. We'll host it from a container, basically. Why use container? People might ask. Using a container will save you a lot of issues. So basically, you will containerize your whole application, and once you make it into an image, you can run it everywhere. It will contain all the dependencies. Back in the days, there used to exist this problem between the developer and the ops team, in which the developer would build and test the application code and everything, and then he would take the code as it is and send it to the operations team. After the operations team tried to run the code on the operation or the servers, it would fail. So the issue was different, maybe dependencies, different runtimes. Maybe the developer built the application using Java or whatever the case is, and the ops team is using a different runtime. So there was a mismatch. It wouldn't work. So Docker came up with this idea of you could containerize your application into an image, and then you could send the application as it is exactly to the operation team. So there wouldn't be any mismatch or dependency missing or whatnot. So it would work smoothly in the dev and in the operation as well. So without further ado, let's get into it. Let's stop this. As you see, a target directory was built. If you want, you can get into it and see the contents in it and whatnot. Okay. Now let's see. Let's start my Docker engine. Okay, perfect. My Docker engine is pinned up. Right now, if we hit Docker images to see all images we have, you can see a few of them that already have. But right now we want to build our own. So let's say I will be building, already containerized it before. This is the one I containerized before. So let me delete it. Docker RMI. There you go, already deleted it. So if we run again Docker images, you're not gonna see it on the list. So now I'll build it again, ls, and we would run, in order for you to build a Docker image, you need to run docker build -tag, and then what you want to name it or tag it with. And then, a dot which specifies that the Docker file is in this location, in this directory we're in, which is the coffeehouse DevOps project. So this directory. It's gonna take time for it to build, the Docker image. So we'll have to patiently wait. While we wait, I will sip my cup of tea. Oh, that was fast. Now let's see the Docker images. Voila, we already have the coffeehouse-app.v1. Perfect. So now we want to run the image here. So let me copy it. In order for you to run it, currently, as you see, we don't have any, containers running. So in order for us to run it, we will run, in order for us to run the image, we will run docker run -d -port 8080 8080, and then the image name. So docker run -d means keep running on the background, and -p is specifying which port you want it to run in, and then the image name. Perfect. So now if you run docker ps, we could see running containers. As you see, it's reroutable on port 8080. So let's go to the internet and check if it's working. Voila. Now the web Spring Boot Coffeehouse web page is being served from this container, from the Docker container. Now let's stop it. we will stop the container, docker stop the container ID. Now if we run docker ps, you see it's not listed because it's not running. So to list all containers, whether it's running or not, you run the command docker ps-a, which lists all containers regardless if it's running or not. So as we are, let's remove this docker remove. We will remove this container. Perfect. Now if we run docker ps-a, it's not listed over there. Perfect. Now we have the image, docker images. I deleted it earlier from, from Docker Hub. Right now it's listed as you see. Perfect. Now, let's go back. If we refresh the web page, it's not gonna work because we stopped it, we killed the, container. Perfect. We build out the Spring Boot application, we containerized it using Docker, and we tested it locally and it's working perfect. And it's currently hosted, we pushed the image to Docker Hub. Now we want to, deploy the Spring Boot application on Google Kubernetes engine. As we know, Docker is very good, in terms of hosting web application. But in terms of production, for instance, where real users and real traffic, real clients come into your web page, there is the fact of considering latency and, bandwidth and whatnot. So Google Kubernetes is very, very well known when it comes to hosting containers because it self-heals. You can run replicas, it auto-scales. Docker doesn't do all of that. Docker, shines into containerizing your application, but not hosting it. Like Google Kubernetes is well known and betterly suited for that type of things. Now, we will be deploying the Spring Boot on, GKE using CI/CD pipeline, which is today's video. A CI/CD pipeline again. Let's go to the image. As you see, we have our source code. When we're building a CI/CD pipeline, you want to, let's make this full screen. Okay, perfect. So let's say your application, Spring Boot application, is hosted on your GitHub remote repo, as we have seen. And, a developer might go through a lot of struggle of building and testing and containerizing your Spring Boot application locally, and then he needs to push it to a Docker Hub or Artifact Registry, as we have already seen, and then afterwards, he needs to deploy it to GKE Kubernetes. All that step is manual and time-consuming. And let's say we have, for instance, let's say we have different projects, because when you're deploying an application, you don't deploy it directly to production. You deploy it to dev, project, and then staging project, and then it finally makes to production, because we have to ensure that the application is working efficiently and it doesn't, throw up any bugs or errors as soon, as it reaches production. So it has to pass a set of, tests before making it to production. So let's say, we have the dev, and then we have the staging, and then we have the production. Let me make this one bigger. So let's increase the font, 20, perfect. Staging 20, perfect. Production. Perfect. So as you have already seen, let's say we build and test and then we containerize, doing it manually in this development project, and then when we want to go to the staging, you have to go again through the whole process of building, testing, and then containerizing it. And then when we move to the production, you have to again build it and test it and then containerize it and then deploy it on GKE. That process is not automated. So this is where CI/CD pipeline shines in, right? You build everything, as soon as a developer pushes a code to GitHub repo, it automatically, detects the code change and it builds and tests and then containerize your, Spring Boot application. And then it automatically pushes it to Artifact Registry and then it deploys it to Google Kubernetes engine. You don't need to do it manually. You don't need to build it and run the commands, Maven build and test and yada yada, etc. So CI/CD, decreases the deployment time by 50 to 60%, let's say, because you're helping the application to go to the market, to the production instantly without going through the whole phase of building again and again and again, So it automates the whole process, which is the DevOps way of automating the whole thing, software development lifecycle. It's the DevOps way of automating the software development lifecycle. All right, so let's get back. Now we'll be launching our GKE cluster. So right now we just made it to the console. Few things we need to do before moving forward. First of all, we need to create a service account to authenticate to our CI/CD pipeline. In order for us to do that, we need to go to the IAM and admin page, because when we create a service account, our GitHub repo, when it's running the CI/CD pipeline, it needs to authenticate to it using that service account. And that service account needs to have a specific permissions. So for security reasons, it's always good to give it the least privilege, access. So for this course, I'm gonna just give it access to, the things that it quite needs, such as the artifact and registry, the GKE, admin, artifact registry admin. That's it. Okay, perfect. So now what we need to do is go to the service account page. Where's the service account? There you go. So we're in the service account right now. So let me close this. Now we will create a new service account. Let's go to the service account. We will give it the name GCP underscore SA underscore key. Perfect. We can give it a description if we wanted to, like for instance what this service account will be used for. This service account is used Perfect. We'll go create and continue. Now we will give it a role. As we discussed, it's always good to give the least privilege module, like least privilege access for security purposes. Don't give it more than, more access than it actually requires. So for this project, we want access to Artifact Registry. So I'll give it the Artifact Registry. Okay, we give it the Artifact Registry Administrator. which can, control and manage the artifact repositories. We'll give it another role, which is the GKE. Let's say Google Kubernetes so we will give it the Kubernetes engine admin as well. Perfect. We'll continue. And done. Perfect. Now what we will need to do is we need to create a key for it, and then we will download that key and store it in GitHub secrets. Make sure this key is managed by you only, and you have access to it and no one else. So don't show it to anyone, and store it in a safe place. So for me, I will be showing it to you on this video, because either ways this project will delete every resource it has by itself after the time limit finishes. So it's temporary account basically. But in best practice and standards, when you're creating, don't show your service account key to anyone. So let's create a new JSON key. We'll create it. It will store it locally on your computer. Perfect, now it's downloaded. Downloads. Here it is. So now we need to store this key on our GitHub secrets, because that's how you authenticate to it. So we go back to our GitHub. Let's go to settings. And in settings, we go to secrets and variables and then actions. Let's delete this previous key that I stored. It's asking me for authentication when you're deleting it. Perfect. So we will create a new repository secret. We will name it as GCP_SA_key. As for the secret, we will copy everything in here, which contains private information for your project ID, authentication, etc. We'll paste it here. And then add secret. It will take time to create. Perfect. So we have our GCP service account key. Now we go back to our Kubernetes, to our Google Cloud Console. Yeah, we search for Artifact Registry. Artifact Registry, there you go. So we're in our artifact registry, perfect. Now we create a new repository. You can name your repository anything, but for me, since I'm building a Spring Boot application, called Coffee House, I will name my repo Coffee House, COFFEE house -repo. And the format will be Docker. You could pick other formats, but the image that tool will store and use is Docker basically. And we'll make it standard. As for the region, US West 1, perfect. If we go back here, if we keep scrolling down, you could see there's a labels page, encryption page, and whatnot. Labels help you organize your resources. So for instance, I could give it stage. If we're at, let's say, if we're at the dev project, or if we're at the staging project, you could give it dev or staging or prod, label it. So let's say I'm, dealing with the prod environment. I would say stage prod. production environment. Prod. Perfect. So encryption, so we'll be using Google Managed Encryption Key. Okay, perfect. We'll create this, coffee house repo. Perfect. So this is our coffee house repo, but currently there's no image deployed on it. So we will go back to our, CI/CD YAML file, and I will walk you through how the CI/CD pipeline works and how it will go from, having a developer push a code to your GitHub repo, and which will automatically launch a build stage and testing stage, and then containerize it, and then push it to Artifact Registry, which is the repo we created right now, and then deploy it all the way to GKE cluster. So let's go back to our GitHub workflows and CI/CD YAML file that I write it. So perfect. So CI/CD pipeline. I named it Spring Boot Java CI/CD, and I made it on push or pull request events on the main branch. So whenever a developer pushes a code to the main branch, or whenever a pull request is created on the main branch, this whole CI/CD workflow will trigger, which includes a build stage, which includes a Docker stage, which will containerize everything, and deploy stage, which will deploy to Google Kubernetes engine. So before we get deep dive into it, let's go to our GKE cluster and create one. So we'll go to GKE. The mode we will be using for our GKE is Autopilot, mode, which will automatically, provision nodes for you, and it will manage it. It will be managed by Google. So the cluster will be managed by Google as well as the nodes. And there are two types, as I have already mentioned. There's standard mode, and then there's Autopilot mode cluster. The standard mode is, the cluster will be managed for you. The control plane will be managed by Google, but you will be managing the nodes, the worker nodes. So you'll be spinning up the nodes and specify how many nodes you want and whatnot, and auto scaling and all the configurations behind it. And then there's Autopilot mode. The Autopilot mode, the cluster, the control plane will be managed for you. And as for the worker nodes, it will also be managed for you by Google. So you need to only worry about the pods and the containers that you run on it. So everything else will be managed. So for those developers that want the usability and not to have managed the worker nodes, use the Autopilot mode. And if you want deep dive, access into your infrastructure, and for you to be the one to launch more container clusters and whatnot, use standard mode. So let's go to our clusters. We'll create an Autopilot cluster. Perfect. Now we will name our cluster Autopilot Heaven Cluster, and the region we will make it US West 1. US West 1, perfect. So if you want, we could create it right now, but let's just look at different settings and configurations that it has. Fleet registration is for when you have more than one cluster and you would like to manage it in a centralized place. So the fleet lets you logically group and normalize Kubernetes clusters, helping you up-level management from individual clusters to group of clusters. So right now we're just running one cluster, that's it, so we don't need this fleet registration. Let's get next to the networking side. So in here you have the option if you want to access your control plane using DNS. But for now we'll just use the IPv4 address. As we see, we're using the default VPC created by Google and the default subnet as well. If you want your nodes to be provisioned with, private IP, that's it, and not to be accessed by users, from the internet, you use enable private nodes, in which your worker nodes will be spinned up with private IPs, and that's it. So we want, since we're hosting a coffee house application on our worker nodes, I would like to have my nodes have a public IP. So we're not going to tick this box. And here is the slider range for pods. I'll leave it as default, 17. We'll enable observability. Next. Release channels. There are 3 types. There is regular, rapid, and stable. We'll be using the regular, which balance the features and availabilities whenever there is an update. You could specify a maintenance window as well. So, let's say your application is running or receiving a lot of traffic at a specific timing. And you don't want any maintenance to happen during that period where the users are accessing your coffee house and Spring Boot application. So you could specify a time for the maintenance window to occur, which is not the time where the users are accessing your coffee house application. So I don't need this right now. We could specify a backup plan as well, for your Kubernetes to have backup your application on GKE and store it in a specific region. But right now, let's just untick this. You can have security features as well. Enable RBAC, role-based access control for only allowed user. Enable secrets manager for your Google Kubernetes engine and whatnot, and other options as well. We'll leave it as default. And there's AI capabilities as well. Logging and metadata. So we'll leave it as it is. We'll go and create this cluster. So it will take some time for it to launch this, GKE cluster. So we'll have to be patient. While that is happening, let's go back to our CI/CD pipeline. And we will update some few informations. Okay, perfect. So in our CI/CD pipeline, as we have discussed, I made, on push, whenever a developer pushes on the branch main for this workflow to, start and initiate and build and all the jobs that includes in it, or whenever a pull request is created on the branch main. So in here we have the environment, which holds, the data for your, Google Cloud info. Let's say, for instance, project ID. What is our project ID? Because we will be using these environment variables on our code. So I will show you later, but for now, let's update the information over here. So our project ID is not this one. Let me remove this one, go to my Google console and copy my project ID. So this is my project ID, perfect. Let's go back and paste it. All right, so which region is our GKE going to run on? It's not US East 4, let's update that. It's US West 1. Let's copy it. And paste it over here. Perfect. Now the coffee house-repo is our artifact registry. Let's double check just to be safe. As you see, we have our coffee house repo, and that's what we named it. So repository is coffeehouse-repo. As for the image, we named it coffee house. We will leave it as it is. The cluster, we named it autopilot-cluster, which is correct. And the namespace is a namespace we will create on Kubernetes. So, it hosts all the deployment manifest file and all the, service file that we will create at a later stage. Right, perfect. So let's zoom in here. In here, we specified the jobs. The first job is the build job, which runs on, Ubuntu-latest. So whenever we execute a job, it would have its own runner, its own VM, which will execute this job, build job. So for instance, for this build job, we said we want to run it on an Ubuntu VM with the latest version. So the steps is we will check out the code, so which will ensure that on the runner, this, this whole source code file would be available. All the contents of, let's say, so we said, the checkout code action will ensure that, this, repository, everything that it contains, it codes, and, the Kubernetes manifest file, the CI/CD workflow, everything will be available on the runner here, the Ubuntu runner VM. And then on the Ubuntu VM, we will set up a Java, because when we're building the Spring Boot application using Maven, we need to have Java. So Maven is not going to run without Java. So we specified it. And uses we use uses over here because this action already exists in the marketplace. Marketplace hosts different types of actions that is already built for you. So if you want to use an already made action from the marketplace, you use this command uses. As you see, we have this action with the distribution to Marine and Java version 21, and we cache it so the build phase goes smoothly and fast. So in here we run the build and test step, Maven clean-b package, which builds and tests the Spring Boot application, and then upload artifact. So this one is an action that ensures after the application is built, it uploads it to app-jar. And the reason we upload this artifact is on the next, next job, which is the Docker job, it will run on a new runner and a different, VM. So it won't have access to the build the application we built. When we upload the artifact, the next job is going to be a different, it would run on a different VM we specified over here. So once we move to the Docker, runs on Ubuntu-latest, needs specifies that this, job is not going to run except after the build is complete and run successfully. Again, we check out the code, download the artifact from the upload, we uploaded it. From the upload, we uploaded it on app-jar. So on the next job, we download it from this file. Perfect. Now this action authenticates to GCP with the credential, secrets and Google, service account that we created on our IAM. And then it configures, and authenticates the GKE plugin. And then it authenticates and configure Docker and build the Docker image, and then push it to the Artifact Registry. And in the final, job is the deploy job, which runs on Ubuntu. And of course, it's not going to run unless the Docker, job finishes. And then it checks out the code, authenticates to GCP again. sets up a gcloud, and then configure a GKE authentication plugin, get GKE credentials. This one ensures that we're dealing with the same cluster. We run right now. The cluster we created over here, which is being created. And then we ensure the namespace exists by using kubectl get namespace, $namespace. And if it doesn't exist, this is an environment variable, by the way. As you see at the top here, we specified an environment. And in order for us to access this environment variable, we use the $command. So let's go back to the deploy. It ensures that, kubectl get namespace, and it ensures that the namespace exists. And if it doesn't exist, it creates a new namespace. And then it deploys a Kubernetes manifest file that we have on our source code application. And then it updates the image. So it rolls out and updates the image, and then it verifies if the image was successfully, deployed on the Kubernetes GKE cluster. So let's go back to the Kubernetes manifest files. As you see, we have a deployment YAML file, and in the Kubernetes deployment YAML file, manifest file, we specify the kind, which is a deployment, and we give it a metadata name, and we label it with coffee house. And then we say the replica, we needed to have 2 copies of our pods, 2 copies of our coffee house, Spring Boot application running at all times. So what this does is, it compares the desired state to the current state. Let's say in Google Kubernetes cluster, 1 pod dies. So Kubernetes manifest file ensures that, the desired state, which is 2 pods running at all time, matches the current state. And if it sees that, 1 pod is running at the production, it launches another pod into the Google Kubernetes, engine. And in here we specify the template, and then the container info and the image that it will be using. And then we expose it on port 8080. So let's go back. Okay, so this CI/CD pipeline seems good with me. Before we commit it, let's ensure that, the workload is running and the cluster is created. Okay, perfect. So as we see, our workload and our cluster is running. And currently we have 1 pod running on our worker node. So now we will update everything. Right now we will deploy our Spring Boot application. So I would make this, we're currently on the test feature branch. So we'll make it on, let's say, the test branch itself. Test. Whenever a developer pushes to the test branch, or whenever a pull request is created on the test branch. Let's say test. Now we'll save it. This will execute the CI/CD pipeline. Right, we will commit the change. Now we push to the test branch. And now we'll go to the actions. As you see, a CI/CD pipeline workflow was, originated and started. Now it's building. Now let's get into the build stage and see it in real time. The build is complete, and then we go to the next stage, Docker, because we set up 3 stages: build, and then after it builds the Spring Boot application, Docker stage, which containerized the application and pushes the image to Artifact Registry, and then the third stage, which is deploying to Kubernetes cluster. So right now it's at the Docker stage, building the Docker image and deploying to the Artifact Registry. If we have to visualize it, so right now it's building, testing, and then the Docker stage, containerizing it, and then pushing to the Artifact Registry repo that we created. And then at the final stage, it's going to deploy to Google Kubernetes cluster automatically by just having a developer push a code or create a pull request on a feature branch or the main branch, let's say. You don't need to manually build and test and containerize it and then push it to Artifact Registry and then to deploy to GKE cluster. This is where CI/CD shines because it decreases the downtime of deployment. It decreases the downtime of deployment by 60%. So developers have a time to fully innovate and build the source code and not have to worry about the whole process of building, testing one by one at each project, the development project, and then at the staging project, and then at the production project. Now let's see. Right now the Docker, it created the Docker image and pushed it to Artifact Registry. Let's verify that. We will verify if our image is running on the coffeehouse repo that we created. Voila, there goes our image, coffeehouse image. Perfect. Now we're at the stage of deploying, and the deploying is completed as well. It checked out the code, it authenticated to GCP, set up gcloud, configure GKE auth plugin, and then get the GKE credentials and ensure the namespace exists and then create it if it doesn't, and then deploy the Kubernetes manifest file we have seen along with its service, which will make it accessible from the internet because we're using the load balancer service type. So if we get into the Kubernetes and the service.yaml, we ensure that we use the load balancer type, which is accessible from the internet. There is 4 types of service in Kubernetes. The first one is cluster IP, which is having pod to pod or cluster to cluster communication locally without being accessible from the internet. And the second one is the node port, which is good for development stage, have to access your application at a specific node port, let's say port 80, but it's not used for production. And the third one is the load balancer one, which is production grade level, which is what you want to use, and have users access your load balancer, and then it will reroute it to your GKE, and worker nodes and pods. So this is the one we're using right now, and we want to access it on port 8080. So as we know, all the stages and the jobs have completed. Right now, let's go to our cluster and verify that. So we are at our cluster. We will get into our Autopilot cluster. As you see, there's an endpoint and it specifies the region it's deployed in and this current status, which is running. Now let's connect to it. We'll copy this command and run it in Cloud Shell, which will, authenticate to Google Kubernetes engine. Okay, perfect. So let's see, the kubectl get namespace and see all types of namespace we have. First of all, I need to run the command again. I just got into it right away. All right, perfect. We authenticated to it and got the cluster name and the region and everything. Now let's rerun the command, kubectl get namespace. Okay, now we have all these services running. Some of them belong to the control plane and some to the worker node. So I need to get into my namespace that I created earlier, that I specified on my CI/CD pipeline. Let's get into, let me show you. The namespace that we created, which was coffee house. If we go to the deploy, job, you can see here we said kubectl create namespace, $namespace, which accesses the environment variable and names it coffee house. And as you see, we already have the coffee house here. So we'll get into it and make this namespace the default namespace. So kubectl, we run the command kubectl config set -context -current -namespace to coffee house. Let's see. Set -context -current. Okay, perfect. I forgot that, double dash. So yeah. So right now, as you see, the default namespace was updated from default to coffee house. Now, we will see all the manifest files and service files that exist in this namespace coffee house. Let's clear the screen. We will run kubectl get nodes to see all the clusters that are running. We can see we have all these clusters running. And then if we want to see all the pods running, kubectl get pods, we can run that command, which tells you that you have 2 pods running currently. And why 2? Because if we go back to our source code when we're deploying it, and we go back to the manifest file, we specified on the deployment and Kubernetes YAML file, we want 2 replicas, 2 pods running at all time. So this will compare the desired state to the current state. So if the current state in Google Kubernetes is not, is only running 1 pod, let's say, it will automatically spin up another pod and then deploy it to Kubernetes, which ensures that, the desired state matches the current state. All right, perfect. So now we will run kubectl get all. This will show you all pods running and the service, service deployment file that you deployed, the load balancer basically, and where you could access it. So we can access it through this, IP address on port 80. All right, let's copy this and check if it's working. Voila, there you go. Now our Reboon application is being hosted from, our load balancer, external load balancer. Let's get into the workloads. And as you see, this is our, worker node that we deployed. Let's get into it. And you could see where the load balancer is being exposed at, the service load balancer that we deployed, which is the same endpoint as we have seen earlier over here. So if you want to just click on it, and there you go. same result. It takes you back to, to the Bluebeam Spring Boot application that we deployed earlier, with the menus, with the about page, and with the contact page as well. In future videos, hopefully we will integrate Cloud DNS to have, users search our website using a domain name, because using this IP is not going to be very, attractive to them. No one wants to go to your web page by inserting 34.132. No, they want a domain name. So in future videos, we will use Cloud DNS to give our, Kubernetes, a domain name users could, route their traffic to and hopefully access it and whatnot. So that's today's video. Hopefully you enjoyed it and liked today's, lecture and project, and you could use my GitHub repo whenever you feel like, and practice as well all the topics that we discussed. And if you have any questions, you could, ask me in the comments below. And first and foremost, make sure to like, subscribe, and share the video so hopefully someone else could benefit from it. And stay tuned for next projects. Wassalamu alaikum wa rahmatullahi wa barakatuh.